In this video, I'm going to explain how to solve absolute value equations and inequalities. Okay, so the definition of absolute value is of a number is the number's distance from 0 on a number line. Okay, so if I've got a number line here, here's 0. There's 4. There's -3. So the absolute value of 4 is just how many units, how many spaces away from 0 is 4? Well, it's just 4. Right? So absolute value of 4 is just 4. Now the absolute value of -3, 1, 2, 3, 3 spaces away from 0. So the absolute value of -3 is just 3. That's why absolute value takes a negative number and makes it positive, because we're talking about distance. Distance can't be negative. So look at an equation. Here's my first example. I have the absolute value of x equals 5. Well, like we just discussed up here, if I'm looking at a number line, again, I have two possible answers that are going to be 5 units away from 0. So either x can equal 5 or x can equal -5. This is why we have to make two equations or two inequalities when we have absolute value bars. Okay, so it's easy to understand why, like what's happening here. Then when equations or inequalities get more complex, it's hard to visualize it, but the concept and the process is still the same. So absolute value of x minus 8 equals 5. Well, that means x minus 8 equals 5, or x minus 8 equals -5. So to get rid of the absolute value bars, you split it up into two equations. Once you do that, your bars are gone, and now you just solve your equations. Right? So either x equals 13 or x equals 3. Now you wouldn't really need to graph these answers, right? Because it's not an inequality. But there you go. 13 and 3 are my two answers. Now let's go to number 3. Now I have an inequality. Okay? Again, the concept is the same. To get rid of the bars, I have to make two inequalities. Well, one of them just stays exactly the same. So y plus 8 greater than or equal to 3. The other one, we still have our y plus 8, but we have to flip the sign. We have to add a negative. Okay? Those are the two changes that you have to make when you're getting rid of an absolute value bars in an inequality. Now, once you do this process, you just solve your inequality and you graph your answer. So that's a -5, y less than or equal to -11. Now, what happens when you have an absolute value inequality and you split it up is it turns into a compound inequality. So it becomes either an and or an or inequality, and you can know from the very beginning which one it's going to be. When you look at the symbol, this is greater than 3. That means it's going to be an or inequality. Okay? If it was less than or equal to, it would be an and. So I know it's going to be an or. That's just helpful, so you already know ahead of time what the graph is going to look like. So we've got a closed dot at -5 and -11, and we are shading away from each other. Okay? All right, example 4. Same thing here. I need to get rid of the bars. So I drop them and I make my two inequalities. 2a plus 9 less than or equal to 13 stays the same. 2a plus 9 greater than or equal to -13. Now this right here is less than or equal to, so this is going to be an and inequality. Well, let's solve. I have a is less than or equal to 2, and a greater than or equal to -11. Okay, we are using closed dots, and we are shading between. And then there's my answer. Now, when it's an and inequality, you could write this in compact form. So I take my negative 11, less than or equal to a, less than or equal to 2, write it together, make it look nice and neat. Okay, last example here. You can see this one's different from the other two because I have things happening outside of the bars, outside my absolute value bar. So I have to get rid of these numbers first before I can break it up. So I need to start by adding 8 to both sides. So it gives me 4, absolute value of x, greater than or equal to 12. Next I have to divide by 4. That leaves me with absolute value of x, greater than or equal to 3. Now that we're down to the bars, we can split it up, right? So I have to jump over here, but this one stays the exact same. This one I flip the sign, I add the negative. Now this is greater than or equal to, so this is an or inequality. X is already by itself, I don't have to solve for anything, so I can just shade it or graph it. So closed circle at 3, closed circle at negative 3, I'm shading away from the numbers. Away from the numbers? I'm shading in opposite directions. Alright, there you go. That's how you solve absolute value inequalities. Thanks for watching.